Hello guys, it's me Fidelido, and we're gonna try a different topic right now, and I just want to share with you guys our new device used for repairs. And here I'm so excited, and I want to share with you and show you as well this table oscilloscope. Okay, it's around 7K plus, I guess. So here we're gonna unbox this one. We have a little bit of damage here. Actually, I already opened this one, and my phone is trying to focus. Okay, I'll just open it. I already opened this one. So here you'll get two test probe, and we only have the standard times 1 and times 10. So that's 1, and 2 same times 1 and times 10. And here, because our scope is a portable one, we have a USB connector and a type C port here. Type C port for our scope, and of course here there's product instruction or the manual. So probe characteristic, the model, I don't know where's the model here. So cut 2 IEC 1010 times 6 times 10 600 peak 6 100. So we have 6 100. We have a quiet kuya. We have sorry for that. We have 6100 model, and we got the 100 megahertz test probe. Rise time 3.5 nano, and attenuation ratio, as you can see, we have times 10 and times 1. Input resistance, we have 1 mega ohm and 10 mega ohm, plus minus 2% tolerance. Input capacity is 70 pf to 120 picofarad. Max input voltage is at times 1 is 150 VRMS. Cat 2 times 10 is 300 RMS. So that's more than enough for our usage. And compensation ratio 15 pf to here we can compensate for the scope to adjust itself. And humidity and blah 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 blah. Cable length, we have 110 to cm, about 55 gram, and I guess that's it. So we have two pieces of test probe, P10 6100, and product instructions here inside. What else we have? So here it's a nice box, and we have the Fnirsi oscilloscope. It's a quite heavy scope and nice build. Here we have a 1 megahertz scope at 1 gigaseconds GSA per sample, and the model, you can see the model. There's no model here. So maybe this one. Fnirsi 1013D. So it's 1013D, a 100 megahertz scope, and we have here channel one, two channels input, and power and over. I don't know the over. And we have the 1 kilohertz, the signal, and the type C 5.2, 5 volts, 2 amperes. That's quite 10 watts because it's quite heavy because of the battery, I guess. And we have the switch. Okay, just turn it on. I hear a clicking relay. So here, yeah, system setting, the screen. I need to actually, as I use this one, as I operate the scope, I'm looking at the camera screen, so it's quite difficult to adjust. I just try to slant it down because of the reflection of our camera flashlight. So I am filming in a bit awkward position because I'm planking, and it's quite hard to breathe in this position. So we have channel 2, channel 1 here. Okay, that's our capacitance compensator, and just input the signal 1 kilohertz. Okay, we set the scope is set to 1 times 10. So here, run, can't see any. Okay, we are at the DC channel is on. Okay, we are at DC coupling and at times 10, and so we are at 50 volts per division. That's quite, every box in here it's 50 volts. So that's auto set. You can auto set, but you can also add a cursor here. There's a trigger, so the cursor from here, and yeah, so here and here is a touchscreen anyway. By the way, it's a touchscreen, and we have a measurement of 1 kilohertz and a 1.7 VRMS peak to peak. So if I add it like here, so what else? It's quite easy to operate, and it's a move and it's fast. Our trigger is set to auto, and that's a rising, and the trigger mode is at channel 1 because I did not put any test probe in channel 2. So you can drag it here like this, here like that. And how can you set the volt per division? At now we are at 1 volt per division, so just press control here, and you can adjust it like that. So it's quite easy. You can set here, just turn off the cursor. So back to control, and how to set the time per division. Here you can tap it like that, and here at the back, at the left side, you can tap it here. It's quite easy to operate, and it's yeah, that's what I like, Kuya. Thanks, Kuya. You're massaging me.
Yeah.
Thanks. And here we have 1 volt for division. So I guess this is not 1 volt here output. I'll need to check it first. Okay, so if we have 1 volt for division here and here, maybe it should be here 1 volt and 2 volts, 3 volt, 4 volts. I don't have any tester here right now, so you just move on. Okay, what else? What else can we do? You can drag here, and also you can appoint measurements. So we are at channel 1, so here you can press Vmax, Vmin, frequency, and duty cycle here, and you can see there's a duty cycle, and you can turn it off as well. And I already set the VRMS values here, peak to peak. You can see peak to peak. So what else? Time, duty. That's it. That's a very straightforward scope. It's right. Yeah, wait. I'm doing a video here. So it's a very straightforward scope, and it is very easy to use. We have our you can save this like this. Save waveform, save wave, and press menu and picture. You can save it here, and maybe you can drag it. Yeah, no, you can't drag it. So you just can't. You just all you can see is um the screenshot of the waveform. So you can delete it like that. Yes, delete, 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 delete. Just leave it that one there. Return, and that's it. And also what else? This one, brightness. Yeah, so I'm trying to lower the brightness for you to see. And trigger and grid, you can, yeah, you can see the grid settings. I like to see the grid so vividly so I can read it properly. So what else? I guess that's it. For channel 2, you can wait. I'm gonna put on the channel the other test probe. Okay, and here, yeah. So I need to turn on. Right now we are at the 50 volt per division. Just press control, and here you can see this channel 2. Yeah, so we are at, yeah, basically the same. So you can move your channel to here, or maybe channel one at the top, at the bottom here. Or you can also just press auto set. See, and you can tap like that. You can also put measurements for the channel 2 here like that. Both channel have a 1 kilohertz frequency as detected. Okay, so I guess that's it for today's video, and of course I hope you like my very quite direct review. I tried to speak in English because some of my viewers are just from Philippines, and I came from Philippines. I'm here at Philippines, and my other viewers also from other country, and if I speak Tagalog and they can't understand me. So I'm not fluent in English, but I'm trying to speak so that everybody can understand. Yes, that's it. And it's quite heavy, and I love it. I love the design. They did quite nice job, and you can remove it. This one you can remove, and you can put it back. You just press and like that.
Yeah, that's what you do.
Yeah, and I love this because when dealing with switch mode power supply, and you need your bench oscilloscope to be isolated from the grid if you're testing, because if you put some grounding pins on the SMPS, you can short it from the main source. So this kind of scope, a portable one, and it's battery operated, is quite useful in cases like that, and it is definitely isolated, and it's easy to use, and it's portable. Yeah, so that, I guess that's it, and thank you for watching. This is Fidu. Don't forget to like, subscribe, and hit that notification button bell. Yeah,
And there will be more videos coming.
yeah, that's it. That's my son. Hi kuya, say hi to my friends.
Hi.
On YouTube.
Hi friends. Hi.
Okay, that's my kuya. Kuya Dylan. That's my son. So thank you for watching, and once again, bye.
Like and subscribe.
Yeah, I already said that one. Okay.
Me first.
Bye.
Bye.